Hello everyone. So welcome to this new session. So in our last class we have discussed with all the type 1 problems, right? Which were all the non-homogeneous solutions where r of x we had r of x in the form of e to the power ax, right? So now let's discuss about the second type, that is here the r of x is again of the form of some trigonometric functions, that is sine ax or cos ax, where the value of a are constants which would be given. Okay, so now even in this case the procedure to find the complementary functions yc remains the same, that is we need to find the roots and all, but here the particular integral, that is yp, is of the form 1 by f of d into sin ax or 1 by f of d into cos ax. Okay, in this case we need to replace the value of d square by minus of a square. Okay, in what we have to do in the type 1 problems, we need to replace the value of d by a, right? Here what we need to do is, wherever there is, for example, let's take a term if f of d is equal to d square plus 4d plus 1. Okay, in this what we need to do is, we need to replace only the term d square and these 4d with d, right? 4d, we need to keep that d as it is. Okay, only the d square term we need to replace. Okay, that also we need to replace it by minus of a square. Okay, not minus a whole square, we need to be very careful. Minus of a square. Okay, whatever the value of a, for example, if the value of a is 2, minus of 2 square, that is minus 4. We need to replace the value of a by minus 4. Okay, if the value of a is 2. Okay, in this way we need to find the particular integral. Here also we have some of the conditions. If again in case of substituting, if we get the value of f of d as 0, same goes here. We need to take the differentiation of the f of d, that is f dash of d, and we need to multiply x in the numerator. Okay, then again the step remains the same. We need to replace d square by again minus of a square and so on. Okay, yeah, so this was all about the solution of finding the particular integral in the form where r of x is given as sine ax or cos ax, where the value of a is constant. Okay, yeah. So here also we have some of the notes, that is we can apply the same rule for the following functions as well, that is sine of ax plus b or cos of ax plus b, where we need to consider only the value of a, okay, not b. Also we can calculate for when r of x is of the form sin ax into cos ax or sin ax into sin bx, cos ax into cos bx, cos ax is sin bx, by changing into sum. Okay, also we can use the identities for these. We have a certain set of identities for these kind of functions, right? Then sin square x, cos square x, also we can use them by formula. Also after replacing d square by minus of a square, the f of d function transforms into alpha d plus or minus beta. Okay, see, for example, I have told you, right, if let me take one function, that is d square plus 4d plus 4, and let me assume the value of a as sine 2x. Let me take a sine 2x. Here the value of a is 2, right? So replace d square by minus of a square, that is minus of 2 square is 4. So this would be minus 4 plus 4d plus, so let's take this as 5 for a change. So now this will be 4d minus 4 plus 5 is plus 1. See, this is of the form alpha d plus or minus beta, right? Yeah, this would be of this form when we replace the value of d square by minus a square, where alpha and beta are constants. See, 4 and 1, they are constants. In this case we multiply whenever, if we reach this step, after the next step what we need to do is we need to take the conjugate of the denominator whatever we get. Okay, for example, if we got 4d plus 1 here by simplifying, right? Now after that the next step would be we need to multiply the numerator and denominator by 4d minus 1. Okay, that is we need to take the conjugate on both sides. Okay, yeah, so this was all about the second type 2 particular integrals. So now we will solve a few problems related to this. So this goes to the first question of type 2, that is d cube y by dx cube plus y is equal to cos 2x. Okay, yeah, so here the value of r of x is cos 2x, and we can see that the value of a here is 2, right? Yeah, so the first step remains the same. To find the complementary functions, replace d cube by dx cube by d cube y plus y is equal to cos 2x. Take y common, so d cube plus 1 into y is equal to cos 2x. So now we need to put d is equal to m according to the auxiliary equation. So now this would be m cube plus 0m square plus 0m plus 1, right? That is equal to 0. This is again of the form cubic polynomial. Take the synthetic division, take all the coefficients, then try to find the first root. Here see I have written the equation. Press the calc button. First value, let me take it as 0, 1, so minus 1. Yeah, see for minus 1 I am getting the value as 0. So this is the first root. So bring this 1 down. Minus 1 into 1 is minus 1, 0 minus 1 minus 1, minus 1 into minus 1 is plus 1, 0 plus 1 1, minus 1 ones are minus 1, so this is 0. So by this we can write it as m square minus m plus 1 is equal to 0, right? Now for this we need to use the quadratic formula, that is the value of b here is minus 1, so minus of minus 1 is plus 1, minus 1 whole square is 1, minus 4 into 1 into 1, that is 4 divided by 2. So 1 plus or minus square root of minus 3 by 2. M is equal to minus 3 is there, right? So we can multiply it by I square by 2. M is equal to 1 plus or minus root 3i by 2. Okay, so this is your required root. So the total roots which we get here are minus 1 comma 1 plus or minus root 3i by 2. Okay, so we can write the complementary function as c1 e to the power, the first root is minus 1, plus, since of the form alpha plus or minus I beta, so c2 cos beta x, the value of beta here is root 3 by 2 x, plus c3 sine root 3 by 2x into e to the power minus 1 by 2 x, right? So this is your yc. So now we need to find the particular integral. Now to find particular integral yp, we know that the formula is 1 by f of d into r of x. Okay, so yp 1 by the value of f of d here is d cube plus 1 into the r of x here is cos 2x. So now what we need to do, we need to replace d square by minus of a square, right? But here we don't have any d square term. So in order to bring the d square term, split this d cube, that is we can write d cube as 1 divided by d into d square plus 1 cos 2x. So now here we have d square term. So now we know that the value of a here is 2. So minus of a square would be minus of 2 square, that is minus 4. We need to replace the value of d square by minus 4. Minus 4 plus 1 into cos 2x. So our yp would be cos 2x divided by minus 4d plus 1. Again this is of the form alpha d plus or minus beta. So here it is of the form plus beta. So now the next step is we need to multiply both numerator and denominator by its conjugate, that is minus 4d. This is plus 1, right? So now we need to write it as minus 1 divided by minus 4d minus 1. So yp would be, so now multiply 4d to this term, that is minus 4d cos 2x minus of cos 2x, right? Minus 1 into cos 2x divided by, see in the new denominator term we can see that this is of the form a plus b a minus b. So we know that it is a square minus b square. So again write it in the form, that is it will be minus 4d the whole square minus 1 square. So now we can see that minus 4 into, we have d cos 2x here, right? So here we know that the d corresponds to d by dx, right? So that's it. Now we need to take the differentiation of cos 2x. Whenever there is d into cos 2x, we know that d is corresponds to d by dx. So we can write it as the differentiation of cos 2x is, the differentiation of cos is minus sine. So along with that we have here 2x. So we need to write minus 2 sine 2x minus cos 2x divided by 4d the whole square. 4 square minus 4 square is 16. So 16d square minus 1 square is 1. So yp is equal to minus 4 into minus 2 is 8 sine 2x minus cos 2x divided by 16d square minus 1. Okay. So now split the denominators. 8 sine 2x divided by 16d square minus 1 minus cos 2x 16d square minus 1. So again in the denominator term we have the d square term. So again we need to replace d square by minus of a square, where the value of a here is 2. So we need to replace d square by minus of 2 square, that is minus 4. So yp would be now 8 sine 2x divided by 16 into minus 4 into minus 1 minus cos 2x divided by 16 into again minus 4 into minus 1. So that is 8 sine 2x by minus 65, right? 16 4 the 64 and minus 64 minus 1 is minus 65. So this would be plus, because cos 2x divided by, we have in the denominator again minus 65. So here we have minus sign, so this would be plus 65. So your final answer for yp is, I'll write the positive term first, cos 2x minus 8 sine 2x by 65. So here in the denominator we have minus, right? I have just written minus here, so that we get both the denominators same. Yeah, so this is your required particular integral. So now we can write the general solution as y is equal to yc plus yp, right? So therefore y is, what we've got, the complementary function c1 e to the power minus x plus c2 cos root 3 by 2x plus c3 sine root 3 by 2x into e to the power minus 1 by 2x plus the particular integral is cos 2x minus 8 sine 2x by 65. So this is your required answer for this question. Okay. Yeah, so now we'll solve a few more problems. So this is a second question, that is d square plus 4 into y is equal to sine square x. So here this r of x is not of the form cos ax or cos bx, right? It's of the form sine of square x. But we know that we have one formula for sine square x, that is equal to 1 minus cos 2x by 2, right? So we are going to apply this formula itself. Okay. We are going to apply this formula and we are going to replace this sine square x by 1 minus cos 2x by 2. See, so here this is of the form cos ax, right? So we can simplify this. Okay. Yeah, so now we'll solve this. So this, the left hand side remains the same. So put d is equal to m. So this would be m square plus 4 equal to 0. Bring 4 to other side, m square is equal to minus 4. M is equal to plus or minus square root of minus 4. M is equal to plus or minus square root of 4i square. So therefore m we get it as plus or minus 2i. Right? So now we can write the complementary function as this is of the form 0 plus or minus 2i. So this is of the form alpha plus or minus I into beta. So C1 cos beta x, so value of beta is 2, plus C2 sin 2x into e to the power 0x, right? But the value of e to the power anything to the power 0 is 1. So finally we get C1 cos 2x plus C2 sin 2x as your complementary function here. So now we need to find the particular integral, that is 1 by f of d into r of x, where we know that r of x we need to write it as 1 minus cos 2x by 2. So now yp is equal to 1 by d square plus 4 into 1 minus cos 2x by 2. So now we can write it as yp is equal to 1 minus cos 2x divided by 2 into d square plus 4, right? So we can write it as y of p is equal to 1 minus cos 2x divided by 2d square plus 8. Here in the yp we have two terms, as you can see, 1 and cos 2x. So this cos 2x is of the form of type 2 only, but what is this 1 doing here? So this 1 we can solve this by using the type 1 problems, type 1. So in type 1 we know that if we have any constant we can write it as 1 into e to the power 0x, where the value of a is 0, right? So here for this 1 we are going to solve using type 1, and for this my cos 2x we are going to solve using type 2. Okay, see, so now we can split and write this as 1 divided by 2d square plus 8 minus cos 2x divided by 2d square plus 8, right? So where we can consider this as yp1 and this as yp2. Okay, so the final yp we can write it as yp1 minus yp2, since we have minus here, right? Yeah. So now we'll solve for yp1, that is 1 divided by 2d square plus 8. So now we need to replace the value of d by 0, right? yp1 is equal to 1 divided by 2 into 0 square plus 8. This is 0. So 2 into 0 is 0. So the final value of yp1 which we are getting is 1 by 8. Similarly solve for yp2, cos 2x divided by 2d square plus 8. So now this is of the form of type 2 only. So here we have d square, we need to replace d square by minus of a square, where the value of a here is 2. So minus of 2 square is minus 4. So yp2 would be cos 2x divided by 2 into minus 4 plus 8. So yp2 would be cos 2x divided by 2 into minus 4 is minus 8, and minus 8 plus 8 is 0. So now we know that if f of d is equal to 0, we need to take the derivative cos 2x into x, into multiply x if we take the derivative, right? So f of d here is d square plus 4. So now f dash of d would be d square, derivative of d square is 2d, and 4 is 0. So 2d left, so 2 into d, right? but here we had 2 into d square plus 4, right? We have written it as 2d square plus 8. So now it would be 2 into 2d, that is yp2 is equal to x cos 2x divided by 4d. Okay, so here we don't have any d square term, we have only d term, so we cannot replace anything, we cannot add any d term. So what we need to do is, so here take this d common, so we can write here it as, I'll write it, we can write it as 1 by d into x cos 2x by 4. So we know that 1 by d corresponds to an integral, right? We know that integral is the inverse of the derivative, right? So we can take the integration of x cos 2x by 4. So in here we can take x by 4 common outside and we can integrate cos 2x into dx. Okay, so since 1 by d corresponds to the integral, okay, so we can write it as x by 4 into the integral of cos 2x is sin 2x divided by the coefficient of x, that is 2. So final yp2 we get it as x into sin 2x divided by 4 into 2 is 8. So this is your final yp2. Okay, so now we know that yp corresponds to yp1 minus yp2. So yp1 value we got it as 1 by 8 minus yp2 is x sin 2x by 8. So we can write it as, since the denominators are same, x sin 2x by 8. So this is your particular integral. So now we can write the general solution as y is equal to yc plus yp, where yc we got it as c1 cos 2x plus c2 sin 2x plus yp we got it as 1 minus x sin 2x by 8. So this is your final general solution. Okay. Yeah, so that's all for this session. In the next session we are going to solve few more problems. Thank you.